Hi, this is Greg and welcome back. I'm excited to be finally finishing this grinder build after several months of work. I started out by remaking the tensioner slider arm. As I pointed out in a much earlier video in the series, the machining of the original tensioner arm had an unfortunately sloppy dovetail fit. I was able to put a 6/1000 shim in behind that original part to take up the slack, but I was never really happy with it. And I also wanted to make it a bit longer so that it remains completely engaged in the dovetail slot as its most extended position. Well, I didn't have a piece of 3/4 inch steel remaining that was quite long enough for this longer slider arm, so I had to make it in two pieces. And I heavily beveled the ends of both to allow for some deep TIG welding penetration all the way around. And I made several passes to build up those bevels until they completely filled, slightly overfilled, so I could machine them flush. I clamped the parts into to my table while I was doing the welding, but I still got a little bit of warping, but I was still able to clean them up, make them all square and flush without sacrificing too much material. Then I added the pretty chamfer all around the perimeter of the rear face, as I showed in a short video that I'll link above. And next I center found to make sure the dovetail would have equal depth on each side, and then very carefully cut the new dovetail into the part. I removed the part from the vise several times during this process so that I could test fit it into the mating dovetail on the main frame, and then put it back into the vise, hammered down, and trim off a hair more and back and forth until I got a nice tight fit that still allowed it to slide. There's no adjustment gib in this dovetail as is typical in most, so I rely on the tightness, tight tolerances of the machining for a nice slide and fit with no wobble. So now I need to cut the feature into the top of the slider to provide the pivot point for the tracking wheel bracket. I started by die chemming the perimeter, just using the original slider as a template to scribe around. And I roughly cut it out using my portable bandsaw. That saves a bunch of, removes the bulk of the metal to save a bunch of time on the mill later on. And then while machining that feature, I used the mating bracket to test the fit, milling off just a hair at a time until that bracket just perfectly fit inside. Then I center found and drilled the hole for the 10mm pivot bolt for the bracket. And in fact, I found the bolt shoulder was only about 9.82mm diameter, not 10. In the original part, I used a 10mm reamer, and I had a bit of a sloppy fit there too. And of course, I don't have a 9.82mm reamer, so I drilled the hole slightly undersized, and then set up the boring head in the mill so I could, take out just exactly the 9.83 I guess I set it to, so just a very tight fit on that pivot bolt. And once that was done, I used the bolt clamped in my vise as a pivot in order to round the top of the feature. And the thin piece of steel you see here is just to ensure that the arm stays square as I rotate it around the pivot bolt. I also made sure to use conventional milling passes so that it wouldn't grab the part, as happened when I made the original part. Live and learn. Then I center found again to drill and tap the two additional holes that are required in the part. There's a large one at the top for the tracking adjustment screw, and a small one further down for the ball end screw that's going to hold the top of the gas strut later on. And finally, I cut it to length off camera, such that it'll be completely engaged in that dovetail when it's fully extended, and then finish it up with some pretty chamfers at the bottom. So here's the 90-degree guide jig for the grinder table that I made in the previous video of the series. I want to be able to use its inside surfaces as well as the outside for part holding. If I use the inside surfaces, I'll be able to use the jig as like a carrier to slide it into the grinder belt along the table T-slots. But that means the inside surfaces have to be flat, of course. So instead of using cap screws that I used originally, I'm going to use flat-headed machine screws, which therefore need a chamfer. So first use a transfer punch to find the center of one of the 6mm holes that I drilled originally. The flathead screws have a standard 82-degree chamfer, so I bought a set of 82-degree chamfer mills, and I'm using one of them here to chamfer the inside of the hole to accommodate the screw heads. I tested several times with the screw head for the proper depth, just under flush on the table for the first hole, and then I zeroed my quill DRO so that I can make the other two chamfers identical depth. Then I use my DRO to step over by the known hole spacing to make the internal chamfers in the other two holes. And that's the finished part. Very simple. New idler arm here installed, much tighter tolerances, so it's much tighter. I can just show you now that it's working great. The first time test here on the bench. The tracking is very responsive. You move it back and forth within, fractions of an inch here. Got it just riding on the outside of this wheel, which is where I want it. Everything's all squared up pretty well. I can zip it up to full speed. It's kind of scary when I first did this. It sounds pretty scary, all right. You do a lot of damage if you got in there. But everything's holding together nicely, and it sounds nice and quiet and stable and smooth. I'll turn it down again so you can hear myself a little bit better. So next step is to tear it all apart and finish it, do the finishing work. I plan to use, let me show you some grinding here first. First time grinding. Now I don't have the ceramic platen behind here yet. I don't want to stick that on until I have it all finished. But I can actually make some sparks now and finish some corners. They look pretty good. So I can't wait to actually use it. So I've just taken a Sharpie here and marked off my plan for finishing. I'm going to paint red, this sort of nice red color, some of these big pieces because I physically just can't fit them into my oven for powder coating. So these will be red. Then I've got some smaller pieces going to be black powder coated. I put BPC all over a lot of the black powder coating parts. This will be black powder coated again too. A bunch of these individual brackets and stuff, black powder coating. Black paint for the base. Again, I'll just touch up the paint there. And then the parts that are going to get scratched, I'm going to use the Oxfo blue, like gun blue kind of stuff to treat the table and this main arm here that slides in and out because they would get scratched if they were painted or powder coated. So that's it. So I say next step is tearing this thing all apart into its individual pieces and start to finish it. And I tore it all down and organized the parts on my workbench, and the parts are going to get painted this burgundy color, and the parts are going to get powder coated the black, and these parts are going to get Oxfo blued, and finally the base and the strut that are going to get painted black. And there's a box of other parts over here, the nuts and bolts, all organized and labeled for where they came from. And for all those parts are going to get powder coated, I used the Scotch-Brite wheel to polish them up. I did this for some of the other parts as well, make everything pretty. Then I did small batches of all of the parts in my ultrasonic cleaner, which you can see running here. It took quite a while to clean all the parts up. They're all polished and ready for powder coating. So now on to the surface finishing steps. I started by painting all the burgundy parts off camera. Then I changed my mind about the platen frame, wanting to cold blue it instead of painting it, because it's likely to get scratched. So I used acetone to remove the paint and did a very light fly cutting of the front and back surfaces, making them all nice and smooth again. I found that I could lightly press my rubber mallet against the ends to quiet the chatter, giving a better surface finish. Now I wanted to stamp some degree indications into the platen frame angles, so I die chemmed them, scribed some center lines, and punched them at 45, 30, 22.5, and 10 degrees. And then as soon as I did, I realized what a dummy, that last one's supposed to be 15 degrees. But I kept on going for now. I painted the punched area to heavily fill in the numbers. And then I moved it to the mill with the idea that I could just ever so delicately mill off the surface paint without touching the metal, leaving only the paint numbers. Well, that kind of worked. But I nicked the metal a little bit, marking it up. In hindsight, another very light fly cutting of the entire surface would have been a better idea. Anyway, I wasn't happy with the 10 instead of the 15 mistake, so I decided to mill a depression in that area, removing the punch numbers to start all over again. So I repunched the degree numbers properly this time and filled them with paint again. This time I used a razor blade to remove the excess from the surface and a bit of acetone to carefully remove what was left, and that worked out better. Then I cold blued the entire surface, followed by oiling with some well-used motor oil. And I also blued and oiled the other parts in this set as shown on the top of the frame here. The red degree markings show up pretty well, but would have shown up a lot better if they were white on black instead. The bluing was also a little bit blotchy around the milled depression area, so I later used a black Sharpie to improve the blackness there, and the numbers show up better. And here are those other blued parts, oiled up and looking good. So before starting the powder coating, I set up a tarp from floor to ceiling in a corner to catch the excess powder. I also found earlier that if you have parts with small nooks and crannies, then preheating the part can help to get that paint to stick and melt into those little crannies. I won't show you all the dozenous parts that I powder coated. This is just one typical part being shown. Each part is hung by a copper wire in an inconspicuous area to provide ground contact for the operation. The powder itself is electrically charged positive by the machine, so it's attracted to the grounded part and wants to stick on there. And then I'd use that same wire with needle nose pliers to take the part and move it into the oven for baking without disturbing the powder. I made a little trivial wire resting place for the parts to cool down out of the oven as another part was moved into the oven for baking. And I found that after the powder just started to melt, then going an additional 20 minutes at 425 worked out well.
So here we have all the parts that make up the grinder laid out semi-artistically on the table here. From the base, which is painted in this, supposed to be a low luster black, but it came out pretty lustrous. I didn't make the aluminum wheels, of course. Here's all the main frame parts, and the sleeving and the platen painted in this burgundy. I didn't make the levers other than putting in the threaded rods and pinning them. Here's the black powder coated stuff I did yesterday. Turned out pretty nice. And then the parts that I did in Oxbow blue. The platen frame and the table and the T-nuts and so on. And finally the brass bits, the handles and knobs that I machined earlier. So that's the entire grinder, apart from the machine screws that hold it all together, all laid out. So now it's time to put this all together again and give it a test. Final assembly. I'm using Loctite blue on these bracket pieces, starting with these the rear sleeve and these brackets with some Loctite blue to make sure they stay on there good and tight. The other side. Okay, that's oriented up. That's the top. So now I can fasten the sleeves to this piece. I don't want these guys in because they're going to get the brackets through them. A bit too much torque on that. Okay, now to fasten the sleeve to the main plate. It's lined up properly. Throw a couple of screws in there. Okay, all good there. And now these brackets go on. I'm going to use some blue on them. Loctite. Tighten these guys up, and we're good. And repeat basically the same operation up here. A couple in the back here, the M6s. Get them started. Why aren't you starting? Awfully close, but it looks like I need to shave the back of this off just a tad. Okay, I basically just took off the thickness of the powder coat, plus maybe a few thou more. And hopefully these guys are going to fit in here now. Optimistically, I'll put some blue Loctite on there. That guy in there, he goes in there. Push that out a bit. Okay, there we go. And that bolts in. And that bolts in. And we have space. Okay. So now on with you guys. On with you guys. Okay, just confirmed on my photos that this is in from the back. So let's tighten her up. And while I'm here, I will put on this part. Get them clamped down. There we go. And that clears just barely, which is as it should. And then tighten this guy up so the plunger goes as far as it can. Right there. That's good. There we go. All good. Oh yeah. We have success. Be this bracket. No slack. And the wheel. Okay. Get this out of the way. And there he is. And clamped on. There he goes. Good. Goes there. And a bunch of table bolts. Where are they? Start them off. Get the lever in there. Okay, we have a lever. And that goes on here. Which way do I want it? I think I want it the other way, don't I? Yes, I do. This way. Right. Gravity. There we go. And now I'll get these guys on. That's good. Tight but not too tight. So here we go. One, two, three. I just want to make sure, yeah, that they are significantly shallow of that, so the platen can go on there without problem. This guy goes in here. Alright, put this back together.
Well, okay, we're really in the home stretch now. Just a few more things to install before I can test this beast. First, I tightened a cable gland around the incoming wire from the VFD and secured it through a punch-out in the motor electrical box. And by putting a 3/4 inch scrap of steel plate under the motor, it raised it up just to the perfect height to get its 4 12mm mounting screws installed with the grinder in the horizontal position. Then I wired up the ground and the 3 220-volt connections from the VFD inside the motor box, making sure everything was tight and secure. Then I installed the rubber gasket and the cover for that box. Next came the 6.5 inch drive wheel. It's a tight fit over the drive shaft and the key, so it needed a little persuasion with a rubber mallet. And then it's secured with a small Allen key that tightens down through the wheel hub onto the key in the shaft. It was a lot lighter and easier to move the grinder onto this bench by first removing the main attachment arm and table. So here I am just sliding that assembly back into place again. I lightly wiped off the platen face with some acetone and then peeled off the backing from the 3M VRB tape that's supplied with a ceramic platen and stuck that platen into place. It fit perfectly, of course, because I'd machined the metal platen to fit the ceramic platen's dimensions earlier. I used the platen adjustment screw slots to get it perfectly squared and just barely proud of the belt idler wheels. You'll need your x-ray vision here to see through my body. Then I loosened the tensioner lever and put on a fresh belt. This one's a mild 120 grit to start with. And here I'm moving the grinder into its final position onto the bench. The garage door at the left can still be opened fully with the grinder here. And I screwed it down to the bench top. I might get some bigger caliber screws or bolts later on, but these seem to hold it just fine. Then I plugged the VFD that I made in part 1 of this video series into the 220-volt wall socket, turned the grinder on slow using the control box that I made in part 2 of the series, and adjusted the belt tracking, which is really nice and solid. I tried it out for the first time with the ceramic platen now installed, using a 120 grit belt. I increased the speed several times till I got some decent sparks as I rounded a corner on a piece of scrap metal. I wanted to try some more serious metal eating, so I swapped to a 60 grit belt, turned it up to almost maximum speed, and now I can make some serious sparks. And then finally, I pivoted the grinder to its horizontal mode, adjusted the table to the belt, and made my first horizontal sparks. Everything checks out just great. That finally brings us to the end of this video, but not quite the end of the series. I plan a video to show more of it in action, to highlight the differences between my grinder and the original Phil Vandelay plans, and what I might do differently if I were to make another one. I'll probably also make a few more table jigs for different purposes. So I hope you'll subscribe and join me again. As always, thanks for watching.